Hello and welcome to What's New in Vectis 2025.2. So Vectis is our high-fidelity CFD tool for solving real-world challenges in combustion with e-fuels, thermal management and general fluid systems. Our aim is to give engineers fast, accurate predictions that reduce development times and improve decision making. In the next few slides, I'll walk you through the key updates in Vectis 2025.2 and how they support your R&D and CAE workflows. This release focuses on three areas. Firstly, we have new functionality, faster chemistry through chemical kinetics clustering. We have better dual fuel models, improved flame speed physics, and smarter solver convergence, plus optimization links with Mode Frontier. Second, we've improved the user experience. We've added a new help system, a new map editing tool, easier CPV table setup, and a new bulk curve editor in our RPost post-processing tool. Finally, workflow enablers have been added, so improved sensors, multi-cycle triggers, automatic data compression, and an upgrade to our Nsight translator. Overall, 2025 is faster, more accurate, and easier to use. Our first improvement is functionality, and that's our detailed kinetics chemistry acceleration. So chemical kinetics give us very accurate chemical combustion predictions, but it's traditionally slow because every cell solves for a large number of species and reactions. For transient engine cases, this can become extremely computationally expensive, so users often have to choose between long run times or simplified chemistry. In this new release of Vectis, we've introduced automatic clustering. With this, cells of similar thermochemical states are grouped together, and then the chemistry is solved once for each of these clusters, and the results are then mapped back into the calculation. This cuts the kinetic run times by up to 2 times while keeping accuracy essentially unchanged. The benefit is simple. We get high fidelity kinetics, which becomes practical for everyday design work, not just for special research cases. And all of this is directly available in the GUI under the chemical kinetics options. But as always at Realis Simulation, we've provided default values which should give you the optimum speed up for your chemical kinetics runs. Our next new feature is dual fuel combustion, and this is becoming a much more common simulation in the heavy industry, heavy duty and large engine applications. Things like diesel piloted CNG, hydrogen, ammonia and similar systems. These engines can be quite difficult to model because the two fuels have completely different ignition behaviour, and the interaction between the pilot and the main fuel strongly affects the ignition delay, heat release and stability. In this new release of Vectis, we've introduced a new dual fuel auto ignition capability specifically designed for these engines. We can now use detailed ignition delay tables for both fuels, which allows us to model pilot assisted ignition and to capture the combined effects on ignition timing across different blend ratios and different operating conditions. This leads to a much better prediction of the start of combustion, ignition delay, heat release evolution, and eventually knock or misfire risks. Overall, it's a major step forward for exploring low carbon dual fuel strategies and support the transition away from conventional diesel. The model is set up directly within the RTZF combustion model within the auto ignition edit panel and is easy to set up directly in the GUI. The next new improvement targets spark ignition combustion, and spark ignition combustion is highly sensitive to local fuel air mixing. In real engines, we often see significant variations in mixture strength, particularly around the spark plug and particularly at different loads. And capturing these effects accurately is difficult with conventional flame speed models. In Vectis 2025.2 we introduced the new Lewis number flame speed and spark kernel models that capture these effects more accurately. So you can enable these options directly within the GUI, within the combustion, flame speed and spark ignition settings, and activate the Lewis number models, and this gives better combustion rate predictions, particularly near the spark where the flame kernel forms and grows, resulting in simulations where we get good predictions from different load cases using a single set of parameters from each case. The next improvement is again improving runtime. So sometimes during a simulation, during a particular time step, one of the equations stops improving even though the rest are still converging. These stall residuals can fool the solver into thinking that the time step hasn't converged, which leads to extra iterations or even false convergence failures. In Vectis 2025.2 we've introduced a new stall detection for equation residuals. The solver checks for stall behaviour using 3 methods, either moving averages, residual increase detection or trend analysis, and then it temporarily removes the stalled equation from the convergence check. This reduces iteration counts while keeping the physics fully accurate. You can enable stall detection in the global solver settings within the GUI by simply activating stall and convergence detection. We've also improved our sensors in this release. Many engine simulations contain parts that move significantly during the cycle, pistons, valves, rotating galleries, etc. Until now our sensors were fixed in space, which meant they couldn't follow these features. Users often had to approximate the movement with multiple sensors and then do manual post-processing at the end of the simulation. In this new release, sensors can now follow the moving boundaries. You simply assign a moving boundary ID to the sensor and it will automatically inherit the same translations or rotations as that component. And this works for both volume and surface sensors with no extra motion setup. It makes diagnostics of things like piston gallery cooling, rotating flow tracking, oil jet fill ratios straightforward and accurate. And it's a big improvement on usability for anyone using moving geometry applications. The next new feature is our link to Mode Frontier. Optimizing engine designs often means exploring very large parameter spaces. Previously, we could link Vectis to Mode Frontier, but it required a lot of manual steps. Things like scripting, file handling, and custom setup, which made optimization workflows harder than they needed to be. In this new release, we've now provided dedicated Vectis nodes inside Mode Frontier. These automatically map parameters, run multiple case studies, and then extract the output metrics without any manual scripting. If you simply create a multi-case project within Vectis and then a corresponding rpost report file, you can then load these straight into the new nodes within Mode Frontier and run the simulation. It makes optimizing workflows much faster, cleaner, and far easier to adopt. The next improvement is rpost bulk editing. So our post-processing tool rpost now includes a new plot manager that lets you bulk edit plots. Within this you can edit entire pages, multiple plots, multiple axes and multiple curve sets all in one place. This means that you can apply calculations, adjust formatting and update whole multi-page reports in a single step rather than having to edit each plot one by one. It significantly reduces the time spent maintaining large rpost documents and makes report creation much more efficient and easier than ever. We've also introduced a new map editing tool called RMap in this release. It's a much smarter and faster way to build and edit multi-dimensional maps directly inside the RDesk environment. It replaces the old ND map editor with a more modern interface direct spreadsheet, import, and clearer visualization tools. The aim here is to streamline the whole mapping workflow and give users a more unified, efficient experience when creating or editing maps across the Realis toolchain. We also have a long list of smaller enhancements across Vectis. For example, vsolve now supports binary CPV tables. We've reduced the size of post files by improving the output of spray data. The R-Geometry tool has improvements for triangle file import, and the R-Viewer has new massflux extraction options. There are many more options and improvements like this within this release, all aimed at smoothing everyday workflows and improving overall usability. And finally, let's just have a brief look back at the key features of the last two releases, which may be of interest to you, and if they are, please contact us for further information. We've added parallel CPV table creation in previous releases. We've enhanced our NOx emissions. We've improved heat flux modeling. We've added improved surface meshing tools, and we've added, for user experience, the very powerful session comparison tool. In summary, Vectis is continuously improving to help you address your most pressing engine challenges and to make it the world's best CFD toolchain for powertrains. So I hope you've enjoyed this short presentation to the new features of our second release of 2025. Our team is here to provide more information about these features and help you adopt them to enhance your CAE processes. If you do have any questions, please contact us at support@realis-simulation.com. I hope this has been useful. Thank you for your attention.